rules of the hardware. You guys, engineers, did a lot of hard work for the hardware. I am not. I'm a software engineer, and the project I'm working on is called a TEA. The T means trusted execution and attestation. Because we don't have enough time, I'm not going to go through all the slides. Oh, by the way, I forgot to share. Give me a second.
Of course, don't worry, don't worry. It's
Okay.
format, don't worry. And it's a very interesting concept that you have. I really like the idea of the concept that you have formalized. So
yeah, it's very different than you guys doing. You guys doing the hardware, the TPM, HSM. I heard it pretty cool, but my project actually is a application. I can see it's an application on top of TPM, but not only on the TPM, but also on the blockchain and WebAssembly and IPFS. The reason we have the project is we trying to have a so-called trusted computing decentralized cloud. Probably we shouldn't use the word cloud because cloud is, as far as I know, is kind of a centralized data center stuff, but we trying to do everything decentralized. The concept actually coming from the blockchain because the blockchain can do a lot of the things we cannot do before in the manner of a decentralization. Just like a Bitcoin, Bitcoin is kind of a bank, but it's no center. People can trust each other without a common centralized authorization. So that is a cool concept. But we try to do the same thing, but we are not going to do. So far, we don't want to do any like a financial related. We just do a computation platform. Probably can answer this. It's actually we can see we are trying to rebuild the cloud, the computing platform. So you actually can delegate or we can say offload your computational work to our new cloud. But the differences between our decentralized cloud versus the like a Amazon EC2 or Google Cloud, Google Function is we actually do not own any computers. Just like Uber, Uber is one of the biggest taxi company in the world, but Uber doesn't own any taxi. Or Airbnb, it's like a hotel franchise, but Airbnb doesn't own any hotel. We actually trying to build, hopefully, the biggest computing platform, but we don't really want to deploy any computer into any data center we own. Instead, we're trying to give the opportunity to anybody. Usually we call those people miners, like you can see on the screen. Like they buy a computer or servers or IoT devices, and they have a security chip on it. For example, TPM, HSM, and those machines actually doing the computational task for our clients. The client could be other blockchains or traditional client from enterprise or like a financial exchange, trading exchange, whatever. They offload their work to the trusted computing cloud. And one of the miners did the work and send the result back to other blockchain, to our client. So they can get the charge. The people pay the money to get them. So they don't really need to send the computation to the Amazon EC2. The benefit for doing that is you actually do not need to disclose a lot of security sensitive information to a centralized computer, like data center like Google or Amazon, in case you don't trust them. And another problem caused by that is because Amazon, Google, they are big names, it's a big brand. So most of the people kind of trust those brands rather than a nobody, right? If I have a machine in my garage, how do you trust me since I don't know you and you don't know me? So that's why the trust comes from, where we can find the trust so that other client can use our services. So trust coming from two directions. One of the direction is you guys are working on, the hardware, trusted computing, the TPM, HSM. This is the hardware part of a root of trust. We also have another part, which probably you didn't talk about a lot, but I work on the blockchain. So that is blockchain. So blockchain is another root of trust. It provides also immutable, but also logical. You can run the we call it smart contract, which is a code inside the blockchain. Because blockchain is immutable, whatever happening in the blockchain, whatever the data stored in the blockchain, you actually can trust. You can trust it. So in this case, we have some of the trust coming from the hardware, the HSM or TPM, another part from the blockchain, and we just combine them together with some other new technologies. We have, let me switch to this one. Yeah. So T is actually based on the 4 pillars. Blockchain, as I mentioned, we use Substrate, which is a development tools. And we also have like a TCG 2.0, we based on the TPM. And also, besides, we also have IPFS, which is providing our network and the storage. And also, we use the container technology. We didn't use Docker. We use WebAssembly. There are a lot of reasons behind, probably don't have time today to talk about why we choose WebAssembly, why we choose TPM, whatever. There's a lot of story behind. Probably we can just skip it for today. Probably in a later time, we can have another talk specifically on the T project with a lot of decision made. Because you guys are working on TPM, probably today you can focus on why we choose TPM rather than other technologies, other projects are using. Typically, it's called enclave, like Intel STX or ARM Trust Zone. I was asked so many times why we choose TPM. They always consider TPM as old technology. It was there 20 years ago. Why we choose this top technology instead of using the Intel STX? So the reason is very simple. Multiple reasons. First is we actually focus on not the data center, but on the edge computing use cases. Like we can see currently we have small IoT devices, we call them sensors, and we have edge nodes. I can see in the middle there, the green, blue cloud. And on top of that, we don't have cloud. We don't trust cloud. Instead, we have a T project over there. We connect all the nodes together in a P2P network. We don't transfer the data, especially the data if it's in plain text, because we don't trust anybody. What we do is we actually do the consensus between the nodes. That means if you trust another guy, another node, if you don't trust another node, you don't have to trust. You just check to the blockchain, because blockchain and TPM is 2 things you can trust. So we gather the information from the TPM from all the devices, including the IoT devices, not only the nodes, including IoT devices. And we gather all the information, security information into the blockchain. And in the blockchain, we run some kind of a smart contract, we call it consensus algorithm. And the algorithm will randomly choose, randomly choose some other nodes to verify remote attestation, the nodes you claim you are honest. They can verify the integrity of the nodes and make a consensus on a group of nodes, not only one, because if it's only one node, there is a chance for the collusion. But if you randomly select, for example, like 20 or 30 of the nodes, you cannot predict. And they can run a algorithm we call the Byzantine fault tolerance, and they can decide you are a honest node or not. Then they can send information back to the blockchain, and blockchain can verify all the signature, also a chain signature chain to determine you are good or not. And once your like integrity is already in the blockchain, then other people can check, verify the blockchain, make sure, oh, you are good. So I can send the data to you. So they can have you to run the code or data. The code and data can be encrypted. And because I trust you, I can send the key to you. You can run the computation inside your nodes. And the result, again, is encrypted. And also the blockchain will verify you actually did a great job. You actually didn't get any data breach. you actually ran the code you're supposed to run, and they verify again using some random nodes, they verify again, and send the verification result to the blockchain, so other your client will trust you. They can trust the result is correct. So the whole idea is very similar to IPFS. I'm not sure you, IPFS is called the Interplanet File System. It actually is a decentralized P2P file storage. You actually can store your file anywhere in the it's called the planet or interplanet, and you actually can using the ID called CID content ID. You can retrieve from any other node. You don't really care where you get the node from and who owns the node. You don't have to trust. The only thing you trust is the hash function. Once you get the data block, you can run a hash function. You can verify the CID, so you know, oh, this data is correct. Then you can trust. We can do the same thing. That you don't, of course, we don't run the hash on the result because nobody knows the result. So the hash nobody know. But you can run a verification from the blockchain consensus to verify the execution environment of the other node. So if the node is honest and the computation is running normal, and other nodes, we can see they are verifier, they can run the algorithm to consensus algorithm and also the TPM verification on you, and they can decide you are good and you can trust. So this is what we call it the trust as a service. So we don't do computation. The miners do. What we do, the T network, what we do is we do a trust as a service. We just do the consensus like running on blockchain. We tell other client, this guy is trustable, or that guy probably compromised already. So that is what we call the trust as a service. And it can be used in many cases.
Yeah.
Okay, go ahead.
Just before use cases, do you have some kind of a diagram that explains the steps? Or maybe it sounds to me like you're trying to create like a certificate authority, but for trust, and that's distributed because we're using blockchain. You want to be some kind of an authority on trust, but because it's a blockchain, it's kind of decentralized. Or maybe you want to actually let me not stop you. Maybe first show a use case, because with a practical use case, it would become more clear.
Okay. I probably can give you two cases. One is how the blockchain going to use it, and another one is what actually we do. Right? I think the two.
Like would be some kind of IoT device or edge device as an example. What would happen? Yeah, something like that. Some kind of a diagram.
I'm trying to find the best one for that. Oh, probably this one is better. Probably one or two of them. But anyway, we can start from this one. So what are we gonna do? We have a small devices. Currently, we're using Raspberry Pi plus a small TPM chips on it. So we call that device a HSM, or kind of secure zone. All the data processed inside these devices, we call it secured because the TPM will protect that. And another green part is a non-secure zone, which is outside of the small devices. We run a lot of other services on the green zone, like IPFS, for example, the file system network. We have a lot of stuff. We do need to go through one by one. So whenever a data sent to the secure zone, we have to encrypt it. In this direction, going to the non-secure zone, we need to encrypt it. And then we're going up, we're going to decrypt it. So once the data or code inside the secure zone, it is decrypted because we trust this device. And so we can run in the memory. So in that case, you run a algorithm or code in the secure zone, the speed is native speed. This is very different than other technology, for example, the security multi-party computation or a fully homomorphic computation. That is very heavy. We ran the code actually in native speed, but how we can trust it? So there is a step here. I probably can find the slide to talk about. Give me a second. This is just a measure boot. Everybody knows that, so I don't need to repeat. This is probably, so when the node start, the node actually running on minimized a version of Linux. We're working on that. It's a small Linux distribute. And it can get all the information from TPM because TPM already has the measured boot PCRs. And we have to save the PCRs with the signature into the blockchain. So when you start, you actually have a small data stored in the blockchain, and also you have a signature, and also you have the public key of the TPM. So other people can verify your PCR at any later time. So once you have it in the blockchain, and when you restart, of course, you get a new version of the we call node profile in the blockchain. So once you join the network, and you send a request to, hey, I want to get verified to start work on the network because I want to make money. I want to run like a services to the client to make money. So when you have the request to the blockchain will run we call a VRF function. VRF stands for verifiable random function. So it will randomly select other nodes. You cannot predict, nobody can predict who's gonna be your remote verifier. And those selected node will be your verifier. They can get your profile from the blockchain. Also asking you some random questions like what is currently running situation. They just talk to you to your TPM. So everything has to be TPM to TPM. So all the communication in between using P2P network is encrypted. So it's no way to get like a man-in-the-middle attack. So when the verifier get the data information, it can try to rebuild for example, rebuild the PCR, rebuild the measured boot to make sure that what you claim in the blockchain is exactly correct because it can verify from TPM. In this case, if you are not honest, you try to fool other people, you likely give a correct number, correct number to the verifier in the blockchain. But when the verifier asks your TPM will not lie. The TPM will tell you exactly what's stored in the PCR. And when the verifier try to rebuild the PCR, it will figure out, oh, what you actually boot is not the one you claimed in the blockchain. In that case, the verifier will say, oh, I cannot trust you. You probably already compromised. So it will sign a result, a rejection or negative result to the blockchain. So you are the one of the verifier. Other verifier probably have 20 or 30 of them randomly selected. If like two-thirds of those nodes, all of them, like they sign a negative in the blockchain will reject your request saying you are not trustable. So you cannot join the network. So this is one example how we do the remote attestation based on the blockchain VRF function. The benefit using blockchain, the two ways. One thing is because blockchain is immutable. As long as you start, you save data or claim into the blockchain, you actually cannot change it anymore. It's already there. Nobody can change it. One of the features of blockchain, immutability. Another reason is because the logic in the blockchain can be programmed. So the consensus can be updated. And also the VRF they can randomly choose another node, and you don't know who will be chosen. And no one can predict or control the process. And the randomness can be verified by the VRF, verifiable random function. So other people like blockchain consensus, they can verify if you actually are random selected, you have the evidence. So they can verify if you have some you have the body to try to collude and they send the result back to blockchain, it will be rejected as well because the blockchain can verify, hey, you are not selected. We cannot verify you are selected. So you have no right to do the remote attestation. So your request will be rejected. And this is how the blockchain can help on the remote attestation. So in that case, probably can say the T network is on one part is a network of remote attestation based on the blockchain on this part. I'm not sure I answered the question or not.
Yeah, you did, and I'm very curious to learn. So, did you define the components that are needed, and what is there if someone wants to test something, or what are the building blocks of your TEA? What are the building blocks?
Okay.
Like where is the project hosted? Where people can find more information, stuff like that. Because I see there's a
Okay.
lot of diagrams, and we already been like over an hour with Stefano, and I'm not sure people have time just because it's in the USA it's during daytime. So I just want to make sure that people know where your
Okay.
project is and what are the building blocks. What can they see and try.
Okay. Yeah, I know many of you are coming from Europe. I'm in California, so I have to make everything fast. If you don't have time today, I believe you don't, you can go to our website. It's called the trust.com. The trust, right? We have a dash there.
Yeah.
T is T, right? Rust is a language we are using in building the whole project through UT Rust. If you go there, you probably it's better to go like yeah, it's still under construction. We just release it, building trust, right?
It's normal for
So the
project.
best way to get there is running the documents. You can read some document I'm writing on, and the way you can better is get like this part, the case concepts, and what we use IPFS, we use blockchain trust computing and WASM. So
And I
that
see you have
part
a
could
demo.
be the first you can read, and also you can try. Sorry.
I see you have a demo there. Can you talk a bit about what would we see in the demo?
Okay, so if you can try the demo here, you can see the process. We have 3 demos here, but I don't have time now to run
Yeah,
from end to end.
we can do it
It's
some
very
other
long.
time. It's just to orient the people. What is the demo and what can they
Okay.
try?
Okay, the demo actually runs a very easy task. Because easy is not easy to blockchain. So the use case is like this. So we have a few people. So one people has an image, the image of we have an animal, lion or cat or dog. You have image. Another guy developed a algorithm. We using AI, we using TensorFlow to recognize the image and to tell you, oh, this is it's a cat, this is a dog, or this is a human, whatever. So they don't trust each other. The people who have an image, they don't trust the one who has a code. He doesn't want to send the image to the developer, and the developer doesn't want to send code to the image owner either, because they don't trust each other. Once they send the data over, they probably copy it a million times and sell the image or sell the code. So they don't trust each other. So what it can do is using our platform, the data owner, the image owner can deploy their code, or sorry, the data to our network with a key in the blockchain. And the developer can also deploy a code, the algorithm, a function, I can see the function, executable function, to our network with a key as well. And they both claim, so anybody using my data pay me $10, or anyone using my data on my function or application pay me like $5. And they can deploy to that. And anyone who want to use it, they can start, you call that a task on the network. Say, oh, I want to use Alice image and the Bob's code. And my name is Charlie, and I paid like $15. I want to get a result. So they can say, I create a task, and then I paid $15, and I wait. So after it deploy and submitted the task, our system will randomly choose a trusted node, and they get the data from Alice and get the code from Bob. They mix together in one of the nodes. We don't know which one because it's randomly selected. And they run the code. They can ask them, okay, somebody pay you $10. I need a key. I can decode it. Somebody need your code. I can decode it. Pay you $5, and they can run a result back to Charlie. So Charlie will get a result. So this is a line which is like a 75% confirm is a lie. So Charlie paid $15 to get the result, and Alice, who owns the picture, get $10, and the Bob, who write the code, get $5. So this is the use case in our demo. So if you go through it, it's pretty complicated, but anyway,
Yeah.
so you will know the basic idea.
Yeah, Kevin, I must admit, you have very interesting use cases. I just must admit it. So I wonder, like, what do you need help with? What would you like feedback most for which part of your? It looks like a framework. It looks like not
Mhm,
just one solution. It looks like a big framework, to be honest, with a lot of moving parts. So
mhm.
to the people we have about we had 16, I think now we have about 12 people. uh, if you want to ask them something like please check this and give me feedback, what would that be? What do you
Okay.
want feedback on?
Okay, the two things. First is because I could be the only person who in this group who is not familiar about TPM because I'm not hardware engineer. So one thing is, the first question is from you guys is, do you think this structure is secure enough? So this is one of the biggest questions I concern every day and was asked every day. Many people ask, oh, is TPM secure enough? Oh, I believe it is, of course. Otherwise, I don't talk to you guys. But other people probably still have a lot of concern on, oh, TPM so cheap, right? But it will work, will secure. I have like data. Sorry?
That's a valid question. Let me see if Ian is here. Ian dropped off. Well, we have David here, who is the maintainer of Wolf TPM, and I can tell you that Wolf TPM is being used in aerospace and medical devices.
Mhm.
So for sure, also we have Paul, the creator of Let's Trust, who can also tell you in how many
Hello.
different devices TPMs has been used. So just the notion of being secure, well, it has TCG compliance. That there's a standard behind it, which you do compliance. There's certification of the encryption algorithms. So you have all those layers of guarantees. So
Yeah, yeah.
so if someone does not trust the TPM, there could be a good reason for that, but they need to give you a concrete reason, and then we can talk about that concrete reason. Overall, it's just that the TPM is manufactured by someone that we do not know, and we need to trust that it was manufactured according to the spec. Like Stefanos Scudo HSM has the advantage that they can give you access to third-party audit to audit their HSM. But overall, there needs to be something concrete why they think the TPM is not secure. You can take the TPM as secure as it is for now.
Mhm. Yeah, I totally understand. That's why that's exactly the same thing I explain to other people who ask me the stupid question. But they usually what
It's
they
a
ask,
valid
why they
question.
ask? Huh? Sorry?
It's a valid question. Just it needs to be more concrete. When whoever asks you, they need to give you a concrete example or
Okay.
problem or argument.
Yeah, the reason they ask for two reasons. I think one reason is they probably not very familiar about trusted computing or TPM. That's the first
Okay,
reason.
that's
The
fair.
second reason, yeah, second reason is the most of them are coming from like Intel STX, the camp. So they usually ask me, hey, why don't you use Intel STX? Because they consider the enclave is one of the best solution. So they always change me on that. When I answer that question is based on my understanding is first, Intel STX or other enclave is not like as solid as they supposed to be. There are hackers like already compromise it as one thing, but it's not the main point. The main point is I consider in the future, the Intel SGX probably will not be the mainstream because the edge computing, especially edge AI computing, will become very popular. Those stuff, they probably not using Intel CPU because the majority of the computation is happening inside the TPU or GPU probably. There's nothing to do with CPU. So that's why we
That's a
think,
good point. That's a good point.
yeah, that's a good point.
There'll be more embedded devices, and those embedded
Yeah,
systems products will not be using Intel CPU just because it consumes more power, and maybe
yeah,
it requires more space or stuff like that. And maybe Nico
that's
here,
right.
Nico, who is also doing a lot of work with TPM and he's from Intel, maybe he has some input on that because that's a fair point. I remember at Electronica once we talked with a security architect from Intel that probably a temperature sensor or a smart home let's say, temperature sensor will not be made with an Intel CPU. Who knows?
Mhm.
But yeah, you have an interesting point there about
That's true.
that most computation will happen at the edge. Therefore, security will probably not be SGX based for those devices. Therefore, using a TPM or HSM makes more sense. I don't know,
Exactly.
maybe Paul or Nico, maybe someone could add additional input, feedback for Kevin.
No, you are completely right on that statement. So SGX, if you look at SGX availability, it's starting from a core, for example, core i5, i7 maybe. And a TPM is holistic basically to any Intel Atom or even lower end core device. So you can always use a TPM through platform trust technology or a discrete TPM. SGX is something more premium. It has the confidential computing benefit, but it's not as widely available as the TPM through the other technologies. So, and in the HSMs, I mean, you are also right for also the more smaller device that want to rely on hardware-based security. There, I saw that there are some attempts to add TPMs to them, but sometimes they don't fulfill the electrical and power consumption requirements for those devices. So maybe a smaller HSM, something that provides a just encryption maybe and not the full chain of trust and everything, but something that makes sense for those little devices.
Mm.
It's one of the things that one of the places that are not, I think, fully taken into account yet. So we consider TPM, I mean, I consider TPM for edge computing widely adopted, and that's great. But for the sensors and
Mhm.
actuators, that's an open question yet.
Yeah, yeah, totally agree. So the reason why they consider the Intel STX because they consider the cloud computing is still the mainstream because the servers inside the data center they can run in the Intel CPU with STX. But in my world, I believe that would be a end very soon, and a lot of computation will be happening on the edge. On the edge will a IoT devices like a sensor or some like a 5G terminal or 5G antenna server, which is close to you, not close to the data center. So that device is probably is a AI enhanced is a server, which is very weak CPU, not Intel CPU, probably ARM or even smaller, with like a huge GPU or TPU. So those devices, of course, we cannot use Intel SGX on top of that, but TPM could be used. That's why we're gonna connect those devices together. So create a trust as a service. We don't do computation. Those node AI machine edge can edge server. They're doing the computation, but we just bring the trust in between. So you have to be verified by other people. So the blockchain like do all the governance to have other node to trust you. So that is exactly what we are doing right now. So that's the reason why we don't focus on the Intel SGX. We focus on TPM. So that's our choices.
Great, Kevin. I mean, on that note, I do agree. Is there like if people go on Tirust, is there like a GitHub repo, like where they can see the open issues or the open topics you need help with?
In
Where
the
they,
GitHub, in GitHub,
yeah,
because the project is still very new, so probably didn't see a lot of things from GitHub, but you can go to, let me type it here. It's called a T-Rust.
yeah, and you can open issues on GitHub, and then people can actually see the topics you need help with.
Yeah, yeah,
But please
GitHub.
feel free to show it right now, so because it will be in the recording and I'll upload it to TPM.dev. So
Sure, sure, sure. Yeah, everybody can go to github.com T-Rust. So far, it's even we are the open source, but not a lot of people know that. We just started to being public. I'm recording some videos and writing some blogs, and the website was live like a few weeks ago, and the demo is ready a few weeks ago as well. So we are very new to the open source community. So that's a big chance, and it's my honor to be here to talk to you guys. So it's my
welcome,
pleasure
welcome.
to talk here. So if you're interested, probably can tell more people. Uh, there is a new way of doing trust in a blockchain combined TPM combined WebAssembly combined IPFS kind of solution. I hope to get more people know us and give us some help, not only on technology-wise, funding and marketing, even tech writers. We need all kind of help to get more people know us. We still very nobody, right? No one knows us, but I believe the idea is kind of cool.
Kevin, 1 year ago, nobody knew TPM.dev, and 1 year later, we are 100 people. So every beginning is difficult. It starts slow. So I think you're on the right path. You have many interesting concepts. With the time, you probably focus on one or two of them, and you get some help and you get some feedback and beta users. So I saw that you dropped the key, the link to the GitHub. I'll drop that too. I see Paul is writing. It's 8:30 p.m. in Germany. I need to drop off this call. Talk to you soon.
Yeah,
Congratulations on 1 year on the TPM Dev. So Kevin, I think it was great to have you to present. And please, whenever you have the ready demo to show, you're more than welcome to come back and present again. And anytime you have some questions, TPM or even just security related, join in and ask. Maybe you can provide the slides so I can upload them to TPM Dev at your discretion, your choice. But thank you so
sure.
much. And
Thank
I'll
you.
just, yeah, but I think you have a very interesting concept. I really like the idea. I mean, I had the idea of attestation as a trust. You're talking about trust as a service, attestation as a service. You're talking about trust as a service. And it's great to see someone thinking in that direction. And you try to combine so many technologies together. I mean, it looks like a framework, really. So let's see what happens.
Sure, sure. Yeah. If you're interested, ask me a question. Maybe not today, it's too late for you.
But
And
let's see.
I can
If
have another
someone
time to
has a
talk.
question, we can wait a minute or two. If someone has a question to Kevin, okay.
Too late.
No. I think people were just maybe a bit overwhelmed by a lot of information, but I can tell you, you have some very good concepts there, and I would be very curious to go through your slides and give you more feedback personally, on a direct
Yeah.
message for sure. So yeah, and
Okay.
again, welcome to join again and ask any TPM or security related questions.
Sure. By the way, it's a short question here before
Of course.
we dismiss. Does anybody try to use a TPM on top of any AI machine? Just like NVIDIA has a new, Intel has a new machine as well. Also, Google has the TPU based on this computational mode module. So, do you know anyone that know any kind of TPM already working on this kind of module?
So just to clarify, for example, we have Movidius, right? A Movidius a neural compute stick, let's say. So you mean running a TPM on that Movidius stick and not on the host, on the host system? That more or less is the idea?
Yeah. Not only on the USB stick, but also some kind of a edge computing, edge AI node. Yeah, exactly.
Sorry, can you repeat that? I got cut.
My question is not only on specific like computing node like USB stick, but also some like general purpose AI modules. I know NVIDIA has one called Jetson Nano, I remember, and
So
Intel has a USB stick. Google also has something.
I saw several POCs and university projects trying to do that. Basically, the idea is, or what I saw is to establish trust between your computer and an accelerator, for example, that can be an FPGA or a BPU or or HDDL card, for example. There are some products that do that provide some functionality, but I wouldn't say it's something like it is an industry standard today, right? But we see, I see a requirement on doing that. Why is the case? For example, you create a machine learning model, and you expend a lot of money doing that and a lot of time and resources. And now you have to run that model into, let's say, an HDDL card, right? Which is an PCI attached device, basically. So how do you know that that device is actually the Intel HDDL card and it's not something that is going to run your model, but also copy the model, copy the results? So that's the problem, you know. And I mean, in data center, that's maybe solved by physical security, you know, there is a person actually connecting that. In edge computing, it's much more difficult because if you have a server with an attached PCI Express device, somebody can just take it out and connect their own device. So there is a trust requirement there, right? A trust between the host system, I would say the embedded subsystem, and the attached devices. There are some, for example, there is I think an Altera FPGA that provides some means of encryption, native encryption. So the FPGA accelerator has a way of, you know, encrypting a model for that FPGA and internally decrypt that. It's not trust, but it's encryption. So there is a niche there for running those very expensive workloads with trust assurance, right? And the other one, I mean, the other option is SGX actually. So, you know, if that software vendor wants to put a very expensive workload into other people's computer, they can use the SGX infrastructure, or let's say the Open Enclave infrastructure, to just don't trust the host OS, but just trust the Intel hardware or the hardware. Yeah. So it's a different approach, not requiring trust, but requiring more, you know, as you mentioned, less highly deployable technologies like SGX or ARM Trust Zone, let's say, and it's much more cutting edge. But I mean, there is a requirement still not satisfied. I believe there are some POCs and investigation on that, but not yet solved by now. Yeah.
Very good, very good. So actually, this is one of the problems we are trying to solve, because as I said, the model is so expensive, or the data is very expensive as well. So for example, some clients they cannot share the data to other people because legal issue or whatever. So if we have a trust, a node with hardware trust, and also the blockchain guarantee the trust, so they actually don't have to send the data over, or don't have to say they can send the code or the AI model to my machine, because they can remotely trust my machine. I will not take the model away or the data away.
I want to interrupt you because there is something actually Microsoft are doing in that direction. I don't remember the project's name. I think it was something around confidential computing, but like a separate project that they have exactly to protect machine learning models.
I think I know it. I think I know it.
It's there is something about that. So
Amazon also have, but it's centralized. It's centralized. You have to send the data to their data center. That's a key point. So you cannot have the data inside your domain, the security domain. You have to send the data over to the Microsoft. That's a problem.
I understand, and it will be a more present problem with more adoption of machine learning that we're seeing. So you definitely have something there, and make sure you try to get it out. And you know, I'm really looking forward to a demo. Like that would be awesome.
Well, the demo is running now. You actually can go to our website. You can follow the instruction. You can run it on yourself. It's online.
Okay.
Oh, so do you have the link on the page there? I'm very interested on that.
The link on what?
The link of the demo link.
You can just go to.
You can drop it in the chat, Kevin. Just direct link to the demo page. Or okay.
Well, you just click the button. You go to the home page. There's a button for the try. You click that. You can.
Great.
Go back home. Oops. Experience. You click this. Let me copy it over. It's instruction demo.
Awesome.
Great. Thank you.
But it's not easy. It's pretty complicated. We're still working very hard to make the demo easier for the other developer. So if you got any trouble, let me know. I'm really sorry about that.
Having that button there really helps to find the demo easier. So that's a good one for user experience.
Yeah.
Okay, I have to drop, guys. Thank you. Very, very interesting, Kevin. Thank you for your
Okay,
time. Thank you,
you can
Dimitar.
ask quick question for your
Thank you,
you can
Dimitar.
ask quick question on the website or on our forum. I'm very happy to answer any kind of question. And if a lot of people interested in that, probably can have another chance to explain more in the detail because it's pretty complicated. Will be pretty long. So if you're interested, probably can have another chance.
Okay. Thank you. Bye bye.
Bye. All right.
Thank you.
That's
Bye
it for
bye.
today. That's it for today.
Yeah. I think maybe Stefan wanted to say something.
Thank you. Bye-bye.
Bye.
I want to say bye bye too. That's the thing.
Yeah, thank you. No, as
The
well.
other thing I
It's
want.
fine.
Next time would be, I guess, that David will be having a chance to tell us about the Microsoft Pluton core supporting WolfCrypt, because maybe Stefano, you'll be more interested maybe in having support first in WolfCrypt and then in Wolf SSL. I'm not sure. David is the expert there.
Yeah, we can talk with can talk with him and see what's the best.
We can talk next time or get together just you know,
Sure.
in a separate meeting.
Absolutely.